Hello, good morning, everyone. I hope you had a good weekend. We are on our last lecture today, which is lecture 12. And of course, next week is your final test, as well as your lab number three is going to be due, I think, next week as well. So let's get right into it. Lecture 12 is about the endocrine system. And the endocrine system is basically a bunch of glands that are responsible for secreting hormones, and these hormones will travel through the bloodstream and act on another organ in some cases, or it would act on another gland, or it would have general effect on cells. And it's not the first time we've learned about hormones. Ever since the beginning of Unit 3, we have been learning some hormones here and there. For example, we learned about aldosterone, we learned about antidiuretic hormone, calcitonin, PTH, right? All these things, and estrogen, progesterone, last class as well. So all these are basically hormones. A lot of them will show up again in this lecture, so it will be a little bit of revision. But there are also a bunch of new ones that we are going to go through as well. I will try to present it in a way that helps you remember it easier. But to be honest, there is no quick and fast way of remembering all of it. You still gonna have to put in the work, the hours to memorize them. But try I will. Okay, so here are the key endocrine glands that we'll be looking at, and some of them you're already familiar with. You know about the pituitary gland, you know about the pancreas, ovary, testicles, and even the thyroid, right? And so, for the most part, we're just going to be adding information to what you've already learned. Okay, so we're going to start with the hypothalamus and the pituitary gland. I'm just going to go through the slides with you first, and then I'm going to draw it out for you one more time. Now, we know that the hypothalamus is up here in the brain, and that is called the master gland. Right? I don't know if I told you that name before. Okay, this is the master gland because it controls the hormonal secretions of other endocrine glands, either directly or indirectly. And many of these processes that are regulated by the hypothalamus involves homeostasis in one form or the other. And so it's a very important structure in the brain, right? Without the hypothalamus, many of these processes would go out of control, and we will no longer be able to maintain homeostasis, and that, of course, can lead to death. Now, connected to the hypothalamus is the pituitary gland, and there is kind of like this stalk structure that connects the two of uh, the two things together. Yeah, and this stalk structure, right here, this area right here, that is called the infundibulum. Infundibulum. Okay, I'll show you more about what's in there in a second. Now, just for the sake of reference, there is your optic chiasma. That's where your optic nerves cross the midline. It's right in front of the infundibulum and a little bit under the hypothalamus. And then we have the pituitary gland here. Okay? The pituitary gland, as you may recall, is protected by the sphenoid bone. Sphenoid bone in the skull, the one that looks like a bat. And on top of the sphenoid bone, there is a groove called the sellar turcica, and that is going to be protecting the pituitary gland. And sometimes, I mean, depending on which side your head is looking at, if your head is looking, if the picture, right, sorry, if the diagram is looking to the left, then the anterior pituitary gland is going to be on the left side, and then the posterior pituitary gland is going to be on the right side. I guess my point is, don't try to remember the left is always anterior and the right is always posterior. It depends on which side the head is looking at in the diagram. But generally, the bigger one is the anterior pituitary gland, and then the smaller one is the posterior pituitary gland. Now, we will try to redraw this in a bit, but we do this before actually, very quickly in I forgot which lecture. I think maybe the urinary system one. But there are two separate groups of neurons. Okay, in the hypothalamus, some neurons will extend their axon all the way down to the pituitary gland, and you can see over here the posterior is on the left this time. Yeah, the head is looking to the right. You can also tell by the optic chiasma. Yeah, optic chiasma is always anterior. And over here, the posterior pituitary gland will store hormones that are produced by the hypothalamus. Okay, and then they will be released from the posterior pituitary gland. There are two such hormones. We have the antidiuretic hormone, ADH, for conserving water, and we also have the oxytocin. And we briefly mentioned oxytocin last week. We know it's responsible for uterine contraction, but it also affects the mammillary gland to allow the letdown of the milk, for the milk to come out while the mother is nursing the baby. Okay, so that's like a direct connection between hypothalamus and the posterior pituitary gland. The axon goes through the infundibulum and then it goes into the posterior pituitary gland. When I explained this to you last time, I told you it's like my writing pad is, connected to the computer through wire. Okay, it's physical connection. Whereas the hypothalamus and the anterior pituitary gland is more like a functional connection rather than a physical connection. There is no axon connecting the two structures. In fact, the neurons in the hypothalamus will stop at the infundibulum, and that's where it will be releasing controlling hormones that will regulate the anterior pituitary gland. Okay, so there are two kinds of controlling hormones. Okay, did I write it down somewhere? Okay, I'll write it for you in a bit. Okay, so there are the releasing hormones that would be like green lights, green signals for the anterior pituitary gland to release their hormone. And opposing that would be a group of inhibiting hormones. So by secreting either the uh, uh, um, releasing hormone or the inhibiting hormone, it's able to tell the anterior pituitary gland to either release hormones or to stop releasing certain hormones. Each of the hormones produced by the anterior pituitary gland will have their own green signals and red signals. Okay, so we already learned GnRH, for example, right? That's gonadotropin releasing hormone. So GnRH is only the green signal for FSH and LH. If you want the anterior pituitary gland to release TSH, then you're going to need to have an other releasing hormone. Okay? So each of these things require a different kinds of releasing hormone for them to be released. So let's draw this out just to see it a little bit better, and and then we're going to go from there. All right. So we're going to have the hypothalamus again. And then I'm going to draw the anterior pituitary gland on the left side. Okay, so hypothalamus, and then like that. It's kind of like drawing a butt right there. Over here, this is hypothalamus. And this right here is the anterior pituitary gland. So the anterior pituitary gland makes its own hormone, whereas the posterior pituitary, it doesn't make its own hormone. Okay. It stores, there are only two that we have to know. Stores ADH, antidiuretic hormone, which we've learned in urinary system. And there's another one called oxytocin. And these are produced by the hypothalamus. Okay. So we have neurons that are in the hypothalamus. They extend their axon right into the posterior pituitary gland. There you go, physical connection. And this region, this stalk structure that connects the hypothalamus and the pituitary gland is called the infundibulum. In fun and then dibulum. There you go. I'll give you a moment to draw that out. Okay, this is I guess we don't really need the and like I said, there is the bone right here that goes protects it. It's part of the sphenoid bone. The sella turcica. All right, so the anterior pituitary gland, there are a bunch of hormones that it produces, and we're going to be looking at six of them. Okay, some of these are called tropic hormones. Okay, and there are four tropic hormones. I'll tell you what it means in a second. Let me list them out first. There is FSH, LH, which we learned from the reproductive system. There is TSH and also ACTH. Okay. So these are tropic hormones, meaning these affect another gland. So FSH and LH, as you know, affects the testicles and the ovaries. Both are endocrine glands because they also produce their own hormones, right? We have progesterone and estrogen from the ovaries and testosterone from the testicles. TSH affects the thyroid gland. We'll learn about it later. ACTH affects the adrenal cortex. So they affect another endocrine gland. Excuse me. Another one, the other classification are non-tropic hormones. Okay, so these include growth hormone, GH, and there's something called prolactin, PRL. I'm just going to write the short form here because as we go through the lecture, we will learn their full names. It's better to remember what they stand for because, like I said, sometimes these names is like the full name is going to tell you what it does. Like GH is growth hormone. What do you think growth hormone helps you do? No, it helps you grow, right? So, like I said, these hormones will be produced by the anterior pituitary gland. However, it relies on um, regulatory hormones from the hypothalamus to control their release. Okay, so there are two groups of hormones from the hypothalamus. Right, these hormones will secrete either releasing hormone or they will secrete inhibiting hormone. Okay, so basically, inhibiting hormones will be like no, don't release, and then releasing hormones will be yes, release. Right? Any names that ends with releasing hormones will be coming from the hypothalamus. Okay, so anytime you see something that ends with RH, you know is going to be from the hypothalamus. We have GNRH so far. We're going to be learning two more today, TRH and CRH. And we're going to get into those later, but the point to kind of remember right now is if it ends with RH, then you know it's a releasing hormone, and that comes from the hypothalamus. We are not going to be learning any inhibiting hormones. We'll just be focusing on releasing hormone. But know that they are there. If there are green signal, there must be red signals as well. Okay. Um, that is pretty much it for the moment. Any questions before we dive further into this? Okay. So let's take a look at the posterior pituitary gland first. And once again, the posterior pituitary gland does not make its own hormone. It just stores the two hormones that are produced by the hypothalamus, and it will be released from there as well. So we have oxytocin. Oxytocin causes uterine contraction during childbirth, and it also releases the milk when um, you're nursing the baby. So the oxytocin is interesting because it's an like rather than negative feedback, oxytocin uses positive feedback. During labor, when the uterus contracts, the contraction actually creates a signal that goes back to the brain, to the hypothalamus, which would then trigger the posterior pituitary gland to release more oxytocin, and then the new oxytocin will cause more contractions, and it just kind of feeds back on itself. Same thing happens during feeding. When the baby suckles, the suckling causes oxytocin to be released, and then the milk comes out, and then the baby sucks more, and that releases more oxytocin, and then it will kind of exaggerate the stimulation, right? That's what positive feedbacks are. Negative feedbacks will counteract the stimulation, whereas positive feedback would intensify the original trigger. So that's what happens when you start having a little bit of oxytocin. It just leads to more and more being released, basically, which is what you want during a childbirth. Okay, you want the muscle to continue to contract and have greater contractions over time, so that the baby can push down. And same thing, you don't want to start feeding the baby and then cut off the milk. You want to, continue to supply to have the milk flow to feed the baby. Um, in terms of what oxytocin do in men, it's not really well studied, but it certainly does not perform these tasks. ADH we learned already. It acts on the distal tubule and the collecting duct to help the body to conserve water. Here is flow chart to show you the positive feedback from oxytocin. Um, so the whole thing, like where does it start, right? The whole process begins when the baby's head is pushing towards the cervix. Okay, so when the baby gets too big, towards the end of the pregnancy, and then the gravity kind of pulls the baby down, and the head pushes on the cervix. That's the initial trigger. Right? That's going to go to the brain and causes the oxytocin to be released from the posterior pituitary. Then through the bloodstream is going to get carried to the uterus. I didn't really mention this earlier, but your whole body is going to be exposed to a hormone when it's released into the bloodstream. But not every single cell will react to it. Okay? The only cells with the right receptors will be able to respond to the hormone. It's kind of like the neurotransmitters. If you release the blue neurotransmitters, only nerves that have blue receptors will be able to respond to it, even though everything is exposed to the neurotransmitters. It's the same thing with hormones. Okay, so then that causes the uterus to contract, pushing the baby towards the cervix. Okay, and now there's more pressure on the cervix. That goes back to the brain and release more oxytocin and so on and so forth until the baby is out, and then nothing's pushing on the cervix anymore. And then the oxytocin level will start to uh, go back down a little bit more. Same thing with feeding. The suckling of the baby on the nipples will create impulse that goes back to the hypothalamus, and then the posterior pituitary gland releases oxytocin, which causes the milk to come out. It's called a letdown of the milk, and then the baby sucks more, and then it just keeps on going and going. Okay. I mean, it doesn't really have to be triggered by the baby suckling necessarily. Sometimes, if the mother hears their baby crying, automatically their body associate that with like feeding time, and then sometimes the milk would start to flow um, as well. Yep, there's a question asking about synthetic uh, oxytocin. Is that what it is? Here, the contraction here uses the yeah synthetic. That's right. So like you can administer synthetic oxytocin, and that would trigger a little bit of the contraction. But once that contraction begins, there's no turning back, so to speak. Okay, like they have to go through, like your body is just gonna keep on increasing level, building it up, and causes the baby to come out. Sometimes, like I read about situations where the um umbilical cord is going around the baby and baby's neck, and then the contraction pushes the baby, and it actually kind of chokes the baby. And what happens is very time sensitive. It's an emergency. They need to perform an emergency C-section. Because like there's nothing to stop the mother from having the contraction, even though it's like harming the baby. The hormone is just building up too strong, and then it causes the pushing to keep on happening. And so, you have a very narrow window to help save the baby. And of course, like cutting off oxygen supply to the baby during birth can lead to the baby born with conditions like cerebral palsy, right? You can read more about that if you are interested. Anyway, so here it is. I forgot I have this slide, but that's what I was trying to tell you. The hypothalamus has like a on-off switch to control the anterior pituitary gland. Okay, it's not a direct line that connects the two together. It's more like Wi-Fi control, if you would. And anything that ends with RH, it's going to be coming from the hypothalamus. And like I said many times already, you've already learned about GnRH. right? That's the on signal to release FSH and LH from the anterior pituitary gland, right? In fact, when you sit down on the test, uh, before you do anything, you might want to write down the pathways first, and then therefore you have it in front of you, right? So that way you can refer to it during the test. Okay, like don't bring the pathway with you, but bring blank paper and then write it down as soon as you start the test. Then you have it there to use. Okay, so like I said,
I have a
um,
question.
sure, go ahead.
Yeah, do we have to show the, I know, our paper we bring before the test started to the camera or no?
No, it's okay. I'll trust you guys. Yeah, yeah, yeah. But at the end, you have to take a picture, right? Of what you have. Okay. So there are non-tropic hormones, and then there are tropic hormones. And once again, the tropic hormones are the ones that will affect an other gland, whereas the non-tropic hormones, they will not be affecting another endocrine gland. And so let's look at the non-tropic hormone first. The non-tropic hormones include prolactin and growth hormone. Okay, so let's do prolactin first. Prolactin, or PRL for short, is going to um, uh, start to produce by pregnant women at about the fifth month of pregnancy. And it will continue to be produced after childbirth if the mother is breastfeeding. Okay. So prolactin basically allows the production of milk, whereas oxytocin allows the milk to come out. Right? So those are two different things. Right? You need to make the milk first before it can come out, right? So to make the milk, you need prolactin. Okay, prolactin. It also plays a role in carbohydrate and fat metabolism. It's really amazing, I guess. The milk actually changes the composition as the baby grows. Okay, so at the beginning, the baby needs more fat in the milk, but then later on, the fats kind of decrease over time and increase in carbohydrates because that's what the baby needs at that particular stage. So the prolactin automatically help changes the formula so that it fits the baby's growing schedule. Yeah. Low levels of prolactins in male, non-pregnant, and non-lactating um, individuals. Okay. The other non-tropic hormone is the growth hormone, which is going to help you grow. They primarily target muscle and bones for growth. Bones gets longer, muscle gets bigger, and growth hormone is more important during the early stages of life, right? Once we get to 18 or 20, we don't really grow much anymore after that. Not like physically growing, right? Like you're not going to get taller or bigger, right? I mean, like you can work out to get bigger muscle, and that is not related to growth hormone, though. Okay, that's related to muscle repairing, actually. If a person has too little growth hormone during childhood, then they might end up having pituitary dwarfism, and the opposite would be pituitary gigantism. Okay, so this is a picture that shows the men's tallest, the world's tallest man, and the world shortest person. The tallest person is 8 feet 9, and he actually can't support his own weight. It's too tall. His spine is not strong enough. Okay, and that's why he has to walk with a cane. And then the shortest person is only 21 and a half inches tall. And so these are extreme cases of where growth hormone is not at the right amount, right? And not at the normal amount. All right. So two non-tropic hormone from the anterior pituitary gland, prolactin and growth hormone. Okay. And for the posterior pituitary gland, let's just mentally recall the information. Posterior pituitary gland store and release hormones that are produced by the hypothalamus, and there are two hormones. And you recall what those two hormones are. And just think about it. You don't have to tell me. I'm just trying to repeat myself to help you remember it. And one of them is for giving birth and feeding the baby. That's oxytocin. Oxytocin. The other one helps you conserve water, makes you pee less. That is antidiuretic hormone, or ADH for short. Okay? Cue card is really good for this unit. You write out the hormone, and then on the other side, you can have like what it does, where it's from, and you just kind of memorize it. Okay? Now, the anterior pituitary gland also has four tropic hormones. These are tropic because they affect other glands. They have an effect on other glands. So we already learned FSH and LH. Follicle stimulating hormone will promote egg development or oogenesis, as well as spermatogenesis in men. And then LH is going to trigger ovulation in female, and in men is going to trigger the production of testosterone. We wrote these down last week on a hormone chart, and we actually will be using them as a blueprint, okay, to learn about these other two hormones. So this one is TSH, which stands for thyroid stimulating hormone. And even without me telling you what it does, you can guess by the name, right? This hormone is going to stimulate the thyroid. And you remember the thyroid? It's right here, right? This is where your thyroid is. We previously learned about the thyroid releasing, um, calcitonin. This is something different though. Okay, we have the adrenocorticotropic hormone, and that is ACTH, and it affects the adrenal cortex. Okay, so these are tropic hormones. Okay, please choose something. It's for you, and not for me. Go choose it. Choose the right answers. Okay, we don't have a lot of answers coming in, but that's okay. For the hypothalamus, it produces oxytocin, and then it's stored at the pituitary gland. And another hormone is ADH. Okay, these are the only ones that are produced by the hypothalamus. These ones are from the anterior pituitary gland. These are all from anterior pituitary. Okay, so make a note of that if you um, if you didn't get it right. Okay, here is another one. There are four tropic hormones. What are they? All right. So tropic hormones, we have LH, FSH, and TSH. These affect other glands. They are tropic hormones. And these ones, they are non-tropic. Right? Growth hormone affects muscles and bones. Prolactin, milk production. All right. All right. Let's learn more about the thyroid and the parathyroid gland. So the thyroid gland produces thyroid hormones, which includes T3 and T4. That's what they stand for, triiodothyronine and thyroxine. You can just call them T3, T4. And they have overlapping functions, which collectively increases your metabolic rate. Okay, so it causes metabolism to go faster. It burns more glucose, so it produces energy for your cells. We also know the thyroid gland secretes calcitonin. We learned that from the muscle unit, bone unit, where calcitonin will allow the extra calcium in the blood to be deposited into the bones. And there are regulation through negative feedback. The parathyroid gland also plays a role in calcium level. Right? Parathyroid gland secretes the parathyroid hormone, which then help um, increase the blood calcium level by increasing absorption from bones, uh, filtrate at the kidney, as well as your intestinal tract. And so we learned about calcitonin and PTH previously. Maybe we can review it later, but right now I want to focus on T3 and T4. So I'm gonna go through a note with you. It's called the HPA, and HPA, you know what? I'll just write down here. Okay, so HPA stands for hypothalamic pituitary axis. So it's a control of certain processes in the body that involves the hypothalamus, the anterior pituitary gland, and one thing leads to the other. So we call it an axis. Now we already learned an example of HPA, okay, in the reproductive system. So let's use that as an example to help guide us through the other ones. All right, so I'm gonna use female, okay, female reproductive system, and I'm gonna use like a simplified version of it. All right, so we have the hypothalamus, and in this case, the hypothalamus will release a releasing hormone, which is a green light. Okay, so we call that GnRH. There you go, GnRH, which then goes to the pituitary gland. And that's why I told you to memorize this last class, right? You know what? Let's be more specific. It goes to the anterior pituitary. And in this case, the anterior pituitary gland will release FSH and LH. Now I'm gonna just skip the estrogen portion. I'm just gonna focus on the progesterone in this case. And so it's gonna go to the ovaries. And yes, there is estrogen, but I'm gonna focus on, like I said, progesterone. Now, what progesterone will do is it will actually go back to the anterior pituitary gland and the hypothalamus through negative feedback and shut down GnRH and FSH/LH because you already have an egg in the fallopian tube. There's no need to develop another follicle at the moment, and yeah, and then we just suppress it. Okay. So this is the HPA. We started with the hypothalamus. It's going to involve the anterior pituitary gland, and then there's some like downstream gland that we're going to be targeting, which is why this is tropic hormone, right? And then it will lead to the release of, another hormone, and from that you're gonna have some kind of effect. Right? So in this case, it will be like thickening of endometrium. All right, in preparation for pregnancy. So that's old stuff. We learned that last week. Now we're gonna do the same thing, but for metabolism now. Okay, it would help if you write them sideways, side by side, right, to compare it. So first, we're going to start with the hypothalamus again, the master gland. And then this time, we're talking about metabolism. So it's a different set of hormones, and the green light is going to be a different signal, but it's going to end with RH, okay? And it's TRH this time. TRH, which stands for thyroid releasing hormone. Thyroid releasing hormone. So that's the green light that would go to the anterior pituitary. Remember, every time the anterior pituitary gland needs to release a hormone, it needs the permission from the hypothalamus in the form of some kind of releasing hormone. Okay, so look back at the notes. What hormones do you think is going to come from the anterior pituitary gland under the influence of TRH? What hormone will be released? Give me a second. I'm going to put on my sweater. Anybody? Look at the anterior pituitary gland, all the hormones that it produces. Which one will be released as a result of TRH? TRH stands for thyroid releasing hormone. Okay. Not T3, T4. T3, T4 is further down, but we're looking at the anterior pituitary gland right now. So let's go to here. Okay. These are the tropic hormones. Okay. So we have FSH, we have LH, and then over here, TSH. What does TSH stand for? TSH stands for, well, anyway, I'm not going to go back. I'm just going to tell you. It's probably easier. TSH stands for thyroid stimulating hormone. Okay, so right here is going to release TSH, thyroid stimulating hormone. Okay, so thyroid releasing hormone is the green light for thyroid stimulating hormone. These hormones are related to each other because they both play a role in regulation of metabolism. Okay? So what does thyroid stimulating hormone do? What It's a tropic hormone. So what other gland does it affect? Well, as the name implies, the thyroid stimulating hormone will stimulate the thyroid. And then from the thyroid, you will release T3 and T4. Not calcitonin, even though calcitonin is a hormone from the thyroid gland, it's not related to metabolism. The trigger for that is high calcium level in the blood, right? So this is different. And then what does T3, T4 do? T3, T4 will increase metabolism. Okay? But you don't want your metabolism to go out of control. You don't want it to keep on increasing and increasing. So T3 and T4 is going to go back and it's going to negatively feedback and suppress the anterior pituitary gland and the hypothalamus. Okay, so you understand how these two are both called HPA because they both start at the hypothalamus and then anterior pituitary gland, and then it's going to have some downstream target gland, which leads to the release of other hormones. Okay, so like as soon as you sit down on the test, I would write down something like this. I would write down TRH, TSH, E3, T4. Right, so that's the metabolic pathway. Right, the other one is like GnRH, FSH, LH, and then testosterone or progesterone, depending on whether you're talking about male or female. Do you understand? If not, please ask away. It's a lot of work, I know. Okay. Um, so keep this note with you on a separate, like, leave it on the side for now. We're gonna come back to it and then we're gonna do a third HPA later. But now I'm gonna have to talk about another thing first. Okay, over here. This is let me write it down. Hyperthyroidism. Okay, and then we have hypo hypothyroidism. Okay, and then in the middle we'll just put normal. So just one more time, just so it really gets in your head. At the beginning, we have T. Which one goes first, guys? Is it TRH or is it TSH? RH or SH? Yeah, everything requires a green light from the master gland, right? So the master gland releases green lights, and these green lights are called releasing hormone. So anything that ends with RH is going to be from the releasing hormone. Listen, all these paths will begin with a green light. Okay? So anytime you talk about HPA, the first one must be the RH. Okay? GnRH, TRH, and then later CRH. They all begin with the RH. Okay? And then from the TRH, it is going to go and trigger the TSH, thyroid stimulating hormone. And then it's going to go to the thyroid. I'm going to draw the thyroid uh, because I need it later on. Okay, so there is the thyroid. And then in this case, the thyroid releases T3 and T4. And once again, normally this is going to go back and it's going to stop. Okay. Now, if you have trouble understanding this, let me write it out in another way for you. And this note is getting really long. So at the beginning, you have increase in, once again, TRH. Okay, it looks the same, but it's not, okay? Just watch. After increased TRH, what's the next thing that gets increased? We've talked about it a few times now. Okay. After TRH, what's the next hormone in line? Hmm. High TSH. And then the next stuff, so what's the next thing in line? What comes after that? It's the thyroid gland, and then what two hormones comes out? Yeah, it's like, doing your taxes, right? Tax is almost due. You gotta, get your T3, T4 forms, okay? And then that's gonna increase your metabolism. However, once you have T3, T4, the T3, T4 will go back and lower the TRH and TSH, right? So what happens next is you will have decreased TRH. So you turn off the green light essentially. Okay? And that will lead to decrease in TSH, which then lowers T3 and T4. And once you have low T3, T4, your metabolism is going to go back down. But with low T3, T4, listen for a second, please. Low T3, T4, without the T3, T4, we're basically lifting these negative feedback, right? We're easing the brakes, if you think about it. And once you release the brakes on these things, then TRH can go up again. And then it just keeps on going all day long. And what does that do? All right, let's say this is time and this is a metabolic rate. It keeps your metabolism within normal range. It's not going to go like super, super high, right? It's just going to keep it within an acceptable range. Exactly like your thermostat. The temperature is going to fluctuate around your set point. You set it at 20 degrees. It's not going to go too high. It's not going to drop too low. Right? It's not going to be exactly 20 all the time. Right? It's going to be 20. And then, if it drops, the heat brings it back up. Right? So it fluctuates throughout the day. And this kind of control is negative feedback, right? I told you, negative feedback. It's not like giving birth. That's positive feedback. That's like pushing the baby out, and it exaggerates, intensifies the original trigger. Do are we okay? Before I tell you about what happens when this is messed up, All right. So let's talk about hyperthyroidism. Hyper is too high, right? So in hyperthyroidism, basically you have high metabolism and it can lead to weight loss, increased body temperature, irritability, thinning of hair and nails. Your heart rate can go really high. All this stuff is in the PowerPoint, okay? But there are different causes of hyperthyroidism. One cause is auto-reactive antibodies against the thyroid. Okay? So in this case, what happens is it's a type of autoimmune disease. The antibodies that you produce are not supposed to attack anything in the body, but in this case, they do. They attached to the thyroid gland and it causes problem. Okay, so let's go to the thyroid gland right here. I'm going to draw the thyroid gland. Okay, so this time what happens is the thyroid gland has these autoreactive antibodies that attaches to it. Okay, so autoreactive antibodies continuously stimulate the thyroid. Okay, so it gets really big. Right? When the thyroid gland gets big, it's called goiter. I'll show you a picture later. I think I showed you this last semester. So what's going to happen? Well, because of the constant stimulation, there's a lot of T3 and T4. Lots of T3 and lots of T4. Okay? And so what happens? Right? Lots of T3, T4 means massive increase in metabolism. Which is why you experience weight loss rapidly, because you're burning up all the fuel. Okay? Now, what happens? I want you to think about this, okay? What happens to TRH and TSH when T3, T4 is really high? That's right. When T3, T4s are really high, then it's going to go back. It's going to go back and really suppress TRH and TSH. So you have very little TRH, which means you will have very little TSH. Okay? Which normally would mean your T3 and T4 is going to go down. Because to release T3 and T4, you need TRH and TSH. In this case, we already have a lot of T3, T4. T3, T4 goes suppresses TRH and TSH, and you should lower the stimulation on the thyroid gland. However, the thyroid gland has its own source of stimulation, independent of TSH and TRH, because of the autoreactive antibodies. It doesn't need the TRH and TSH to tell it to release the T3, T4. The antibodies are always stuck to it and always stimulating it. Okay? And so even though we have TRH and TSH levels being very low, you will continue to have T3, T4's level being very high. Okay, so that's kind of like the hallmarks of hyperthyroidism. I'm going to put it right here. T3, T4 levels are high despite having low TRH and TSH level. And so if they do a blood test and they found TRH, TSH are low, but T3, T4 are high, this person has hyperthyroidism. Okay, let's take a look at hypothyroidism. Again, there are different reasons of this happening, but one example we're gonna do is iodine deficiency. Okay, so T3 and T4 are the only hormones in the body. Sorry, are the only thing in the body, in fact, not just hormone. T3, T4 are the only thing in the body that requires iodine. Okay. And so if you don't have enough iodine, then you are not going to be able to make enough T3 and T4. Okay, so iodine deficiency, okay, lack of iodine to make T3 and T4. You don't have the raw material to make T3 and T4. Okay, so here we have the thyroid gland. Okay, let's just draw it big, okay? I'll tell you why it's big in a bit. There we go. And then it's like not really releasing T3, T4. Very little, if any. Okay, that's why it's like trickling. That's what these dotted lines are. Okay, so this is low T3, T4, which means we have low metabolism. Low metabolism. So do we have strong brakes or no brakes? Think about it. What happens to the feedback loop? Is it there? Is it not there? Very strong, very weak. Right? So we need T3, T4 to apply the brakes, right? Since we don't have T3, T4, there is no suppression. Very weak. Okay? Like you don't even have to draw it, I guess. Okay, very weak. Very weak. Right here, right? It's virtually non-existent. Okay, you don't really have to draw it. Okay, but I'll put it there. So what's going to happen to TRH and TSH? Well, since the brakes are not there, then you will have increased TRH. The body thinks you're not making T3, T4. So let's hurry up. Let's, turn on the green light. And so T3, T4 is low. We have high TRH. We have high TSH. And then TSH is like really stimulating the thyroid. It's like, hey, thyroid, what's going on? Why are you not making T3, T4? Go. Right? It's constantly stimulating it. And that's why it's goiter again. Right? So both hypo and hyperthyroidism has goiter as a symptom. Right? Goiter is not indicative of hyper or hypo. You got to look at other stuff. And the thyroid gland gets bigger, but you are not making more T3, T4 because the problem is we don't have the raw material. You can tell me to hurry up all you want. I can't make more unless I get iodine into the system. Right? So this constant stimulation will make the thyroid gland big, but it will not fix the problem. So the situation here is instead of T3, T4 levels are high despite having low TRH and TSH, this one is the opposite. T3, T4 levels are low despite having high TRH and TSH level. Okay, so that's hyper and hypothyroidism. Okay, I am gonna leave it here. Let's have a break. We'll come back at 9:45. See you. Right, let's keep going here. And that is the metabolic pathway, basically. In the PowerPoint slides, you will see a comparison between the symptoms of hyper and hypothyroidism. It's nothing fancy, it's just from online. You can read it yourself. Uh, this is the goiter that I was talking about. And once again, just because someone has goiter without looking at other symptoms, you don't really know whether it is hyper or hypothyroidism. For people with hyperthyroidism, another feature is the bulging eyes right here called exothalamus, which is um, as a result of the autoreactive antibodies. Not only do they bind to the thyroid, they also bind to the muscle around the eyes, and it causes them to become inflamed, and then you have these, bulging eyes features. Just something for you to look at, I guess. Okay, in iodine deficiency, hypothyroidism, which hormone level are expected to be high? Okay, let's see if you can find the right answer from the notes we took. Uh-huh. Okay, so we don't have the raw material to make T3, T4, so the bricks are off, which means we will have high TSH and TRH. So A and B are the correct answers. This next one, um, this is related to the thyroid, but we learned it previously in another unit, right? It was the bone unit. So high level of blood calcium is going to trigger the release of which hormone? Okay. I guess it's a good time to review this with you. So if you have your study guide, there's a flow chart here for PTH and calcitonin. Let's just go through it together. I'm just gonna have to copy it over. Okay. So once again, we learned this before. We learned it in the bone unit um, when we talked about the homeostasis for blood calcium levels. And we need to have, here, we'll say normal, normal blood calcium level. Okay. And basically it's this chart here that we're trying to fill out, but we can do it together. Okay, so there is the normal blood calcium level. And the situation here is you might have high increase in blood calcium level because of dietary intake or because you're taking supplements. So this would be a rise in blood calcium level. And then it's going to go to the thyroid gland, stimulates the thyroid. And from there, the thyroid gland releases calcitonin. And at the time when I was trying to teach you this, I said an increase in calcium will trigger calcitonin. Increase in calcium will trigger calcitonin. What are you gonna do with all the extra calcium in the blood? Well, you can put it in the bone, right? So stimulate the, okay, so it would deposit calcium into bones. And also, we don't need to absorb as much from the kidney. Or reduce calcium absorption from filtrate. All right, so collectively, these actions will bring the blood calcium level back down. And so that's calcitonin. And the opposite is a drop in blood calcium level. Drop in blood calcium level. And what's going to happen? Well, drop in blood calcium level is going to trigger these glands that are at the back of the thyroid gland. Okay, so stimulate the parathyroid. Parathyroid glands. I guess we can put gland here as well. And the hormone is PTH, parathyroid hormone. And what it does is it will increase absorption of calcium from bone. Okay. Release calcium from bone. Increase absorption from filtrate. Calcium absorption, right? And increase calcium uptake from intestine. And collectively, these actions will bring the blood calcium level back to normal. Okay. So basically, three hormones from thyroid gland. T3, T4, they are for metabolism, and then calcitonin, also from thyroid gland, is for regulation of calcium in the blood. All right. That is that.
So can you please come back to the first slide of the where you show the water,
Where I show, sorry,
the
show
water when you start in
this one?
after the break because I didn't follow.
Oh, like these ones?
No, the first one. Yes, this.
This one?
No, the other
This?
one.
This one?
Yes.
Yeah.
This,
Oh,
what is it?
what is this showing?
Yeah.
Yeah, okay, yeah. So goiter, that's what goiter looks like, right? So this is just again, goiter doesn't indicate whether it's hyper or hypothyroidism, right? It's all in the notes. In both cases, the thyroid gland gets big, um, for different reasons. And I was just saying, for people with hyperthyroidism, the antibody also binds to the muscle around the eyes, causing the bulging eye symptoms. Okay. All right. So high level of calcium will trigger the thyroid to release calcitonin. Calcitonin. Okay. PTH is for low calcium. T3 and T4, TSH, TRH, these are not related to calcium. These are related to metabolism. Okay. All right. Next, we are going to be looking at the adrenal glands. The adrenal gland sits on top of your kidneys, and there are two parts to it. The outer part is called the cortex, and then the inner part is called the medulla. And they release different hormones. You might remember the adrenal cortex releases aldosterone when we discussed the RAS system, the RAS, right? The aldosterone comes from the adrenal cortex, but we'll see there are other hormones from the cortex as well. Generally speaking, the cortex releases hormones that helps regulate resources in the body. And these are more for long-term stressful situation, right? And it's regulated through HPA, the hypothalamic pituitary axis, whereas the adrenal medulla is releasing hormones for immediate short-term kind of stress situation. So epinephrine and norepinephrine, these are same word as adrenaline, right? And noradrenaline, and they are regulated through nervous control, right? Hormonal controls usually take longer periods of time for it to come in effect, whereas nervous control is more immediate, right? If you see again like an angry dog running towards you, your heart rate gets up very quickly. That's a nervous control, and it's like immediate danger, short-term stress, and you need to get out of there, right? Or fight the thing. So that's fight or flight response, and that comes from the adrenal medulla. For more chronic level of stress, for example, like, it's stressful because it's exam time, or it's stressful because of financial reason, or, job stability. That kind of stress builds up over time, and it's energy demanding from the body's perspective to remain stressed out. You need a lot of extra resources to maintain that kind of stressful situation, and that's when you need to have these hormones around. Okay, so the mineral corticoids is a group of hormones that would help regulate minerals in the body, such as sodium. Right? So an example of mineral corticoids is aldosterone, something we've learned previously. Another group is called glucocorticoids, and an example of that is cortisol. And these hormones help regulate glucose in the body. Okay, so all of these are actually steroid hormones, and they help increase resource availability in the body, basically. So let's write this out in the notes and see how it goes. Now we're going to go back to this HPA here in parallel with the other two, and hopefully it will make sense when we draw them side by side. Okay, so over here we have resource regulation. We'll say resource availability. Okay, so even if a person is not stressed out, your body will release these hormones to help regulate resource availability. Okay, like if you skip breakfast this morning, then you probably need some extra resources in the body to keep you going. And so this pathway is going to be activated. Um, I'll explain more as we go. First, we start with the hypothalamus again. And once again, the whole point of the hypothalamus in these pathways is to basically releasing hormone. So this one is called CRH, corticotropin releasing hormone. If it ends in RH, you know it's from the hypothalamus. Now the CRH will go to the anterior pituitary, just like the other two examples. Excuse me. Um, so the anterior pituitary gland, in this case, will release ACTH. Okay, the full name is a little bit harder this time. It's adrenocortical tropic hormone. Right? Basically, AC is adrenal cortex. Right? That's where it will be traveling to through the bloodstream, and it goes to adrenal cortex, the outer portion of the adrenal gland. And it's going to secrete two groups of hormones: mineralocorticoids and the main example of that is aldosterone. There are other ones as well. Now I'm gonna put a star here, and I'm gonna put a star right here. The aldosterone can be triggered through RAAS, right? The renin, angiotensin, that kind of stuff that we learned previously. So this is not the only way to trigger aldosterone release. Okay, just want you to be mindful of that. And then there's glucocorticoid. Okay, and then the main one is cortisol. If you have some kind of like acne ointment. Uh, it's this stuff. Okay, it's cortisone. That's the medicine version of it. Okay, they have anti-inflammatory properties. Okay, so what this does is it will increase resource availability. Okay, the detail is in the PowerPoints. We can go through it later. Okay, but that's what it does. Now, I am really hoping you see the theme now. And what do you think these things is gonna do? Well, if you have high levels of these mineral corticoids and glucocorticoids, they will pump the brakes, so to speak. They will go back and inhibit the anterior pituitary as well as the hypothalamus so that we're not gonna have uncontrolled levels of these things. Right? We don't want to waste the resources. But here is the thing. Here is the thing that's different from the other two pathways. Okay. You can stop the brakes through the central nervous system. CNS can override the negative feedback loop when during chronic stress. Okay, so like I said, stress is an energy demanding state in the body. And so the CNS, the central nervous system, will override these negative feedback loops when a person is chronically stressed. Okay, and there are many reasons why people can be stressed out for long term. Illnesses, right? For example, loss of a loved one, so on and so forth. And once you override the negative feedback loop here, then the cortisol level will basically keep on rising. Right? You no longer have the bricks in place. Okay. It kind of looks like this. Okay, let's say this is time again, over here time, and then this, let's just say cortisol. So normally we have this fluctuation, but if you introduce chronic stress, then the feedback loop is not there. It will keep on going up, 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 and then now you will reach some kind of new level. Yeah. So this is chronically high levels of cortisol when a person is chronically stressed. Okay, we're not talking about immediate stress. If you're in a dangerous situation, then it's not cortisol we're talking about. That's too slow. We're talking about uh, epinephrine, right? And norepinephrine, the fight or flight response. So we don't have overrides for the other two system here, not naturally anyways, but we have a natural override here when we're stressed. Okay. So let's take a look at the PowerPoint slides again. Like I said, there are two major groups of hormones from the adrenal cortex, the mineralocorticoids and the glucocorticoids. An example of each is aldosterone and cortisol. Basically, aldosterone helps maintain uh, salt and water in the body, whereas glucocorticoids helps regulate other resources that would boost glucose level. And here it says cortisol raises blood glucose level in at least two ways. Of course, you can break down proteins into amino acids. And then we learned last semester that these amino acids can be fed into the different stages of Krebs cycles or glycolysis, right, which ultimately gets converted into energy. But in addition, these amino acids can be taken up by the liver and be converted directly into glucose as well. You can change how fat is being metabolized and convert them into carbohydrate as well. And the ultimate goal is to make more glucose available so that you can use it to maintain this stressful state in the body. We wrote this already. So this is the negative feedback loop that would go back to the anterior pituitary gland and hypothalamus, but the central nervous system can override it. So over long term, if the cortisol level is consistently high, is actually not good for the body. Right? So a high level of cortisol is going to interfere with growth, not surprisingly, because you are taking all these resources, all these proteins and all these fats, and you're converting them into glucose to be used, rather than being used for growth. Yeah. The immune system is low. Right? We need proteins for the immune system. The complements, the antibodies, all those are proteins. And if you are breaking down all the proteins, then you don't have much left for the immune system. Sexual function, cardiovascular functions, all these are going to be impacted by high levels of cortisol in the body. Also, very stressful situation, high level of cortisols will impact the hippocampus. And as you may recall, hippocampus is where you create long-term memory. So, it's kind of like a paradox here, right? People are stressed during exam, and then the stress actually makes it more difficult for them to remember the stuff, and then they get more stress, right? So that's why even though it's exam time, it's important to take care of yourself and try to find things to lower your stress, or at least bring it to a level that's manageable. Okay, so that's the adrenal cortex. For the adrenal medulla, which is the core, it releases epinephrine, aka adrenaline. They are the same thing. And norepinephrine, noradrenaline basically have similar function as epinephrine. They creates the fight or flight response. Your heart rate goes up, your respiration goes up, dilation of pupil. Basically, you're getting the body ready to either run away from the threat or to um, deal with the threat. This picture shows you how the adrenal medulla is directly controlled through nervous system. Right? So the impulse originates from the hypothalamus in response to acute rather, short-term stress, and it travels down the spinal cord and then goes to the adrenal medulla, which is why it's a very quick pathway. It's through action potential. For long-term stress, it takes longer to build up the cortisol level because it's a hormonal pathway. And then once it gets to the adrenal cortex, we have the two groups of hormones that I told you about. Okay, so epinephrine, I just told you, is secreted by the adrenal medulla.
They are not hormone, uh,
Which ones?
epinephrine and norepinephrine.
They are a hormone, but then the point is the trigger of the release of these hormones are much quicker because the trigger is through a neuronal pathway, as opposed to a hormonal pathway for the other stuff. Okay.
Okay. Thank you.
Mhm. Mineral corticoids. We just did this. It is aldosterone. Okay, so last we're just gonna talk about the pancreas, the pancreatic hormones, um, and let me see what's going on here. I'm just taking a look at my slide here before I showed you. Yeah, we're almost there. Okay, so pancreatic hormones. That's where the pancreas is, behind the stomach. You should know that from earlier classes. The pancreas has both exocrine and endocrine function. Exocrine means it is going to be secreting through a duct, and that is what we saw in the digestive system. The pancreas is able to secrete pancreatic juice, right, that contains various enzymes to help with digestion, and that goes through the pancreatic duct. But the pancreas also has endocrine function, which means it produces a hormone that goes directly into the bloodstream. Now, the groups of cells that are producing these hormones in the pancreas, they are called pancreatic islet cells, or islets of Langerhans. But again, you don't have to necessarily memorize you know, the person's name. Okay, pancreatic islets. And these cells are either alpha cells or beta cells. Okay, so two hormones here. We have glucagon and we have insulin. Both of these are from the pancreas. Just remember there is an A in glucagon, so it's produced by alpha cells. Yeah, glucagon and insulin. I guess the easiest way is for us to fill in the chart right here for you to see. There's another flow chart here for insulin in the study guide. So let's copy it over and then we'll do it. There we go. Okay. So again, the whole thing here is that we need to maintain normal blood glucose level. Normal blood glucose level. Okay. So over here, you have increased blood glucose level. Now, why would that happen? Well, it's very simple. After a meal, okay? Even though you're not eating anything sweet, your blood glucose level is going to go up after a meal because then you're gonna have carbohydrates, right? Carbohydrates are made of glucose, so that's gonna boost your blood glucose level. And what's gonna happen when you have high blood glucose level? That is going to stimulate beta cells, beta islet in the pancreas. And the hormone that we need in this case is insulin. Again, if you need help remembering, if there is an increase in glucose, you need insulin. Just like when there's an increase in calcium, you need calcitonin. Okay, they both have in the word in the hormone. Okay, so increase of that thing trigger the release of these hormones. So what does it do? Well, insulin is going to tell body cells to take up insulin, glucose rather. Okay, so take them up, burn them, All right, use it to produce ATP. And if there are too much glucose around, then you can store them in the liver. So liver converts excess glucose. This is something that we learned last semester, very early on in the course. It's called glycogen, right? Glycogen is the storage form of energy in the liver. So collectively, the cells are going to be taking up the glucose. The liver is going to mop up the excess one, and these action will lower lower blood glucose level and bring it back down to normal. Right? So people who have type 1 diabetes, for example, they can't release insulin and they cannot do these things, so glucose levels remain high. People with type 2 diabetes, they make insulin just fine, but then their body does not react to them anymore. So even though they're insulin, but the body's not able to take them up. Okay, so here the opposite is low blood glucose. And why would that be a situation? Skipping a meal, right? Skip a meal or fasting. That's gonna lower it down, and it will what did I say here? Stimulate. Yes, stimulate alpha islet cells in the pancreas. And this time, it is going to release glucagon. Glucagon. And how I remember this is when glucose are gone, then we need glucagon. When glucose are gone, we need glucagon. So where do we get the glucose back? Well, remember, we store a bunch in the liver, right? From previous meals. So it's going to promote the liver to convert glycogen back into glucose. And then that's going to increase. It's going to raise blood glucose level. Bring it back to normal. Okay. So these are antagonistic hormone pairs. I'll write down for you on the side. Um, we learn about, for example, aldosterone and ANH. Aldosterone is going to increase blood pressure. This is going to lower blood pressure. And we learned about PTH and calcitonin. And then now we have glucagon and insulin. So you can memorize these in terms of like opposing functions, and that's like, 6 hormones uh, dealt with here, right? If you remember the HPA, that's an additional 9 hormone. I know, easy for me to say. but hopefully that's going to give you some guidance. Okay. And that's it. That's all there is. Okay. Let's see what other slides we have. That's basically what the flow chart shows you. What insulin is antagonistic to insulin. We wrote it down just now is glucagon. You can try these questions later. Okay. And the rest of it are just stuff that we've done. Okay? We talk about the gonads, which involves, the testes and the ovaries. So we have the testosterone, estrogen, and progesterone. It's just old stuff. Okay. Oh, there's a new gland here, the pineal gland, which is at the back of the brain. This one produces the hormone melatonin, and you might have heard of melatonin before. Melatonin helps you go to sleep, and in a low light room, your brain starts to secrete the melatonin, and then you feel sleepy and you go to sleep. Okay, it doesn't keep you sleeping though; it just puts you to sleep. Uh, Thymus is a little bit lower. Thyroid here, thymus down here. And we previously learned about thymosin in lecture 3. It's a hormone that helps the lymphocytes to differentiate, to grow, specialize in the T cells, for example. Okay, so that's in the thymus. And that is all for the hormones. I think I have two more poll questions here. Let's try that out. Go ahead. Okay, thank you. The hormones secreted by the thyroid includes T3, T4, and calcitonin. So C, D, and E. Okay, how about adrenal cortex? Adrenal cortex. Okay, so adrenal cortex is the outer layer. We have the mineralocorticoids. An example of that would be aldosterone, and the glucocorticoids. An example of that would be cortisol. Okay. And that is it. You survived the whole course. All right, congratulations. You still have to do the quiz, lab quiz number 3, and the final test, of course. So please prepare for that. I do have to double check though, because I don't remember. Oh, the thymus. Yeah, someone's asking me about the thymus. The thymus is right here, and it releases thymosin, which is a hormone that helps you mature the the lymphocytes. This is not the last class. We will have another class on Wednesday. I will review the hormone stuff with you. We'll fill in the hormone charts. Like I want you to have some time to digest this stuff first, okay? And then we'll take up the rest of the study guide with you. I know you have the answers. I post the answer for you, but it's different when I go through it with you. So let's take a look at what's going on here. Your lab quiz is due next Monday. Yeah, so you still have time to prepare for that. And then you will have the final test. So we finish we will finish the endocrine system on Wednesday for sure. And we probably have some time to do the a little bit of review as well. So we're not going to have a class next Monday. You can use that to prepare to study. And then you will take the you will do the lab quiz and then you will do tests as well. So this Wednesday will be our last face-to-face class. Okay. Just bring the hormone charts, bring the study guide for lecture 12, and we will take them up. Okay. That's it for now. Thank you. See you all on Wednesday. Bye bye.